topic, alkenes. So a quick revision, alkene, like if two carbon atoms are there, then it will be eth, and because there's a double bond ene. If three carbon are there, prop, double bond ene. The position of a double bond is also important. If double bond is between the first two carbon atoms, so it's butte because there are four carbon atoms. One is the position of the double bond, and ene is because there's a double bond. But a double bond can also be with the second between the second and the third carbon. So the closest number is two. That's why it is bute to ene. And when two molecules have the same molecular formula but different structure, so we call them as structural isomers. Or if the position of the functional group is different in a structural isomerism, that's called position isomerism. Then we discussed the formation of a sigma and the pi bond, the bond which is formed by complete overlapping of the orbital. You can see the orbitals actually overlap in this region, so that will result in a formation of sigma bond. But the bond which is formed due to attraction of the electron due to opposite spin, their the axis is parallel but not an overlapping complete, then this will result in a formation of pi bond. Stereoisomerism, due to the presence of a double bond, it restricts the rotation in the geometry, which result in a formation of stereoisomer or geometrical isomer. If the heavy groups are on the same side, we call that as cis or Z. If heavy groups are on the opposite side, we call that as trans or E. But if identical groups are there, we cannot compare the masses, so it does not have a geometrical isomer. I'm quickly going through this part because already in the last lecture we discussed this all in detail. Just a quick revision because today I will discuss the questions also related to alkene. That's why I'm revising this. So you can see the heavy groups are on the same side, so it is Z. But heavy groups are on the opposite side, so it is E. If heavy groups are there and identical groups are there on the same side, then we can also say Z or cis. If identical groups but in opposite side, we can say trans or A. But the condition is it should be identical groups when we are comparing. Reactions of alkene plus hydrogen result in a formation of alkane. The mechanism is important. We discussed already that what happened like in case of hydrogen, which is H2. H2 means hydrogen bonded with another hydrogen atom. When the molecule collide with each other, this create a distribution, partial positive on one hydrogen and partial negative on another. The one which get partial positive is attracted towards the one which is partial positive is attracted towards the pi bond, the electron rich side, and the partial negative hydrogen will take both of the electron. This will result in a formation of carbon cation, and then that carbon cation attract the hydrogen ion, the negative ion, and form a bond. So this result in it's called electrophilic addition reaction. Why electrophile? Because the reaction started by attraction of a species or the substance towards the electron rich side. The condition for this reaction, we need nickel as a catalyst. Type of reaction, addition or reduction. Why reduction? Because addition of hydrogen is known as reduction. Then the second reaction was reaction with bromine or chlorine. Again, electrophilic addition reaction occur at room temperature. This is like if alkene is reacting with bromine in the beginning, because the two identical atoms are there, they have the same electronegativity, so even distribution of the bond. But when the molecule collide with each other, the bond pair is repelled, so it's shifted towards one side, so one will be partial negative, other will be partial positive. Partial positive is attracted towards electron rich side, and the partial negative will take both of the electron. Then this will form a carbon cation. So two possibilities are there, like the first carbon which is having a double bond may have form a carbon cation, or a second carbon may form a carbon cation. It depends on if carbon cation is surrounded by more carbon chains or alkyl groups, that will increase the strength or stability of the carbon cation. So in this case, because even if the left hand side or the right hand side carbon cation is formed, like if the left hand side the carbon cation is formed, only one carbon chain is there. If the right hand side carbon cation is there and bromine was attached to this one, then this is also having one carbon chain. So both have the same possibilities. So for symmetrical alkene, it's one possibility. For asymmetrical alkenes, in which the molecule is not having a symmetry, it can form or result in a formation of different carbon cation. One will be major product, another one will be minor product. Same thing, reaction of hydrogen bromide with alkene. So how we can explain this reaction the same way, but in this case, because the bond is the bonds initially were non-polar, like there is no distribution of the electron in the beginning, unequal distribution. But here from the beginning, because the bond is formed between hydrogen and bromine, bromine is more electronegative or having a greater tendency to attract the shared pair of electrons, so it will have partial negative and hydrogen will have partial positive. And this hydrogen, which is partial positive, attracted towards electron rich side, and bromine will take both of the electron. Then it can form carbon cation, left hand side or right hand side, both are possible. Then the bromine, which is having a lone pair, attracted towards the carbon cation and result in a formation of the product. If you have, this is symmetrical alkene. When we say symmetrical alkene, it means the two carbon which are having a double bond have identical carbon chains. But if it is asymmetrical, like it does not have a symmetry, then two possibilities are there. You can see butanene. In butanene, one of the carbon is having only one carbon chain, but the second carbon, which is having a double bond, is having two carbon chains attached to it. So when the partial positive hydrogen, partial positive attracted towards the electron rich side, then what is the possibility? This is first possibility, the first carbon may get a positive charge, carbon cation, or the second carbon may get a carbon, form a positive ion or carbon cation. But which one is more stable? So when we check the stability, we check how many carbon chains are surrounding. So this is one carbon chain and this is a second. So two carbon chains are surrounding. In this case, only one carbon chain is surrounding. The length of the chain is different thing. It does not affect the stability. It's about the number of the carbon directly attached to the carbon cation. So in the first one, two carbon chains are attached. So this will be a major product, means majority of them carbon cation will be like this. This will form, but this will be a minor product, like small amount of carbon cation in this form. That's why you can see the major product is the one which we have a um, stable carbon cation surrounded by more alkyl groups as compared to the second one in which only one carbon chain is attached. This is the all part which we already discussed in the last class, last session. Then if the question is why, like the carbon cation which is surrounded by more alkyl group is more stable, because what happened, these alkyl, if the question is, if they say why, like the carbon cation surrounded by more alkyl group is having a greater stability, so what is the reason for that? Because these alkyl groups are known as electron releasing group, because carbon is not having greater tendency to attract the electron, so they tend to, instead of take the electron, they tend to give the electron. So when these two carbon chain try to give their electron to this carbon, so what happen, overall positive charge will decrease. As the overall positive charge on the central carbon will decrease, what it will do, it will reduce the like reactivity, or it will make it more stable. That is why that tertiary means when three carbon chains are attached, the tertiary carbon cation is more stable than secondary, and secondary is more stable than primary. So if I draw each of them, So when I draw each of them, like there's a carbon, it is connected with 3 carbon chains. This is a carbon cation. So this is known as a tertiary. Then carbon the carbon cation surrounded by 2 alkyl groups, 2 carbon chain. That's called secondary. And the third one, the carbon cation surrounded by only 1 carbon chain or 1 alkyl group. So if the carbon cation surrounded by 1 alkyl, here we have 1 alkyl group. This one we were having 2 alkyl groups. And the first one, the tertiary, we were having 3 alkyl groups. So this one, when 1 carbon chain is attached, that's known as a primary. So when we compare the stability, because look, the positive ion will attract the negative charge. The stability means if it's a stronger attraction towards the negative ion, like it will, so it will react instantly, it will be less stable. So how it reduces or how it increases the stability, the carbon, like the carbon chains or alkyl groups are electron releasing group. So they try to give their electron to the carbon cation. As they try to give the electron to the carbon cation, so this positive charge on the carbon cation will decrease. So it will not react easily or it will be more stable. Here, 2 carbon chains tend to donate their electrons. So the positive ion will decrease, but compared to tertiary, it will be less stable. But in case of primary, only 1 carbon chain is try to donate the electrons, so the positive ion charge will decrease. But compared to the tertiary and secondary, this will be least stable. So when we compare the stability, a tertiary is more stable. The tertiary carbon cation is more stable than secondary, and the secondary is more stable than primary. Is it clear? Any doubt in this part? Because the carbon is not having a greater tendency to attract the shape. It belongs to group 4. So as we move across the period for the non-metal, their electronegativity increases. So carbon is group 4, then there will be group 5, 6, and 7. And so less attraction towards the electron. That's why we call them as electron releasing group. Any doubt in this part? Then reaction of potassium manganate 7. So potassium manganate 7, acidified potassium manganate 7. This is called oxidation reaction. The term oxidation reaction, addition of oxygen, is known as oxidation. So what it result in a formation of diol. Means a double, you don't have to learn the mechanism for this reaction, just the final product. The double bond will break and OH, oxygen, is added. So what it results, the 2 hydrogen are already there, the OH, the double bond will break and OH is added to the 2 carbon. So what it result, it will result in a formation of diol. So potassium, acidified potassium manganate 7 occur, this reaction can occur at room temperature, and the type of reaction is oxidation because it's addition of oxygen. And what we observe, because in KMnO4 potassium manganate 7, when we write the charge oxidation number, so Mn is +7, and when Mn is +7, it is purple in color. If it is dilute, it will be pink, but originally it is purple. When it react, What it result? It will turn Mn plus 7 to plus 2. So when it is plus 2, it is colorless. So what we will observe when this reaction will occur? We'll observe that the purple color will disappear or it will decolorize. Just the final product is important. The mechanism is not there. You don't have to learn the mechanism for this. Same thing, reaction with bromine water. There is a difference between bromine water and aqueous, like bromine water, aqueous bromine, and bromine in a liquid state. Bromine water means like bromine is mixed in or dissolved in water. So the formula for bromine water is HOBr. You can write BROH or HOBr, both are correct. But if it is bromine as a liquid state, like if they say we have a bromine in a liquid state, then it is Br2. What is the original color of a bromine water? The bromine water is orange in color. What is the original color of bromine molecule? It is red brown. So what we will observe if we add a bromine water to alkene, so bromine added to one carbon and hydroxide added to the second carbon. For this reaction as well, the mechanism is the same way. The mechanism reaction occur like the partial positive negative. Electrophilic addition reaction will be there. So bromine is added to one carbon and OH is added to the second carbon. And what it result? This is colorless, so it will decolorize the bromine water. If we add a bromine molecule, like example, if we add the bromine in a liquid state, so only the difference is the observation in the color. It will also decolorize. But what happened, because bromine is red brown, so original color instead of orange, it will be red brown. And final, it will be 1,2-dibromoethane. So this reaction is also used to test the presence of double bond. Check the presence of a double bond. Uh, as you took in O levels, if you want to test any alkene is there, we used to add a bromine, which will turn from red brown to colorless. Here we have two possibilities. We can add a bromine water or aqueous bromine, which is orange in color, it will decolorize. We can also add bromine in a liquid state, which will turn from red brown to colorless. Then polymerization. What is the term polymerization means? Polymerization means formation of a long chain hydrocarbon when small unsaturated hydrocarbon react. So if we have example CH2 double bond CH and CH3. So 3 carbon, because of 3 carbon, it will be prop. So due to the 3 carbon, we will say it is prop. And because they have a double bond, so ene, so it is propene. But whenever there is this double bond, we call that molecule as monomer. But your monomer, when you want to draw polymer, first thing you should rearrange the structure. So rearrange, your monomer should appear like letter H. You can draw in this manner or the first one, but it's appear like letter H. So first thing what we have to do, we have to rearrange the monomer. So how we rearrange the monomer? In this example, because the 2 carbon which are having a double bond, so these are the 2 carbon which are having a double bond. Then one side, it's having 2 hydrogen. So 1 hydrogen up, 1 hydrogen down. Then this carbon having 1 hydrogen, so up and down. And the second one is carbon chain, so it will CH3. So that's also a monomer. So both are propene. To draw a polymer, what we will do, we will break the double bond and form a long chain compound. So same structure we will draw. So if I draw the 3 units here, I will link them together and put N because this means it will continue. So at the last we will put N. So if you have N molecules of the monomer, this will continue and form the long chain compound. This is called propene. The polymers are named after the monomer, so that's called polypropene. But how this reaction occur, how this reaction started? So this reaction is started with peroxide initiator. Peroxide initiator. What is peroxide initiator? Like the peroxide, R means the carbon chain, then oxygen is there, then oxygen is there, and then a carbon chain. Now, first what happened? Basically, the homolytic bond breaking will occur. So due to this homolytic bond breaking, both oxygen will take their electron back. As they take their electron back, what it will form? R and O. And because there's a free electron, unshared electron is there. So this is known as the free radical peroxide initiator. Initiator means this will start up the reaction. So what happened? Like example, if you was having ethene. So ethene means between the two carbon, there's a double bond and then hydrogens are attached. So this is one molecule of ethene. Then there's another molecule of ethene. N molecules are there. We have like lot of molecules. Now how this reaction occur? So this oxygen will try to form a bond with this carbon. So if oxygen will try to form a bond with this carbon, so if I show the electrons here instead of showing the full bonds, just to distinguish, I'm using like electrons of one carbon with dot, another one is with cross. But because it's the same element, so it should be same symbol, but just for explanation, dot cross. And here as well, dot and cross. Now what happened? This oxygen, what it will try to do, this oxygen will try to form a bond with carbon, one of the carbon. So the carbon will take, means it will break the bond and it will use this electron to form a bond with oxygen. So what it result? It will result in a formation of RO. Then there's a free electron for oxygen and there's one electron the carbon took from the bonding with other carbon. So they will form a bond with each other. Now, this carbon, because it can also form 4 bond. So as the bond will break, so this carbon will have the electron here and it will use this electron to form a bond with another carbon. So now they have a single bond between them. Like the second carbon of the first molecule, now it's having a free electron. That electron tried, because free electrons are more reactive as compared to a pair of electron. So this carbon which was having a free electron, now will try to form a bond with another carbon which is next to it. So this was cross and this is dot. So you can see they are linked with each other. Then this carbon, because now it's a free electron, this electron is used here in a bonding. So this carbon will have a free electron, it will attack on another, and this is like a chain reaction, it will continue until at the last what we have, like how the reaction, how the polymerization end. So at the other end, what happened? The carbon will form a bond with another oxygen which was initially produced, and the chain will close. So basically the molecule link with each other and the reaction started due to the peroxide initiator. Is it clear? Any doubt in this part? So you can see if we are forming an addition polymer, the monomer should appear as letter H, and polymers are named after their monomer. If monomer is ethene, the polymer should be polyethene. If monomer is propene, the polymer is polypropene. Then the use of the polyethene. Polyethene is used to make plastic bags, buckets, bottles. It is flexible and it can easily mold. It's waterproof, chemical proof, and low density plastic. Where polypropene is a stiffer polymer, it is used in utensils, containers, fibers in the rope and carpets. So if you have butene, first what we will do, we'll not draw the polymer from the linear structure. We will arrange in a like letter H and then make a polymer. Then disposal of the polymers like the plastic. So the common disposal, what we use a landfill, like dumping them. So most of the common method of a disposal in UK is using the landfills. But most of the polymer like polyalkenes are non-biodegradable. What is the term non-biodegradable? Means it cannot decompose by itself or take too much time to decompose. So it increases the waste, the amount of the waste produced. Incineration means like burning them and using that to produce electricity. But the problem with this incineration, it produces toxic gases. Then recycling can also be done. But what is the effect? Like when recycling is done, it does not produce the same strength of the plastic when recycling is done, as well as it increases the cost. Some questions now related to alkenes. This question is about hexane C6 and H14 and hex 1 in C6 and H12. What tests would you use to distinguish between hexane and hexene? So how we can test? We can add a bromine water or aqueous bromine with hexane, because the bromine water does not react, so no change, no visible change. But with hexene, it will react and the orange color will disappear, or it will decolorize the bromine water. The next part, hex 1-ene has number of isomers. Include 2 isomers of hex 2-ene, including the 2 isomers of hex 2-ene. Complete the formula of E hex 2-ene. So E hex 2-ene means we have to draw the geometrical isomer in which the position, like the heavy groups, are on the opposite side. So first, to draw this, what we can do, like C double bonded with C. Okay. You can use a wedge and a dash to explain this, or you can just draw the arrows to show the direction of the bond. It's up to you. Both ways it is acceptable. Like showing that one of the bond is into the plane, another one is out of the plane. So we want to draw hex 2-ene. So second position should be the double bond. So this is 1 carbon, 2, 3, and then because it is E, so the other group, the heavy group, should be on the opposite side. So 1, 2, 3 are already there. 4, 5, 6. And then this will have hydrogen. This will also have hydrogen. Now we complete the structure. This will have 3 hydrogens. This will have 2 hydrogen because 2 bonds, 2 hydrogen and 3 hydrogen. So you can see this will become E hex 2-ene. You can also draw in this manner, like the 2 carbon which are having a double bond. So because I need hex 2 means 6 carbon atoms, but the double bond should be with the second carbon. So 1, this is second carbon, third, and fourth, fifth, and sixth carbon are here. And I can write them all together as well. If you find it this difficult, you can write like CH3, CH2, CH2, CH3. So instead of writing CH2, CH2, and CH3, I can write C3 and H7. Or you can write in this manner. So this has become E hex 2-ene. Is it clear? The geometrical isomer of E hex 2-ene. E means the heavy groups should be on the different side. So when we compare hydrogen with CH3, CH3 is heavy. When we compare CH2, CH2, CH3 with hydrogen, so CH2, CH2, CH3 is heavy. But I cannot say this as a trans. Why I cannot say this as a trans? Because the heavy groups are not the same type. When heavy groups are of the same type, I can say I can say E or trans. Same type of heavy groups, but on opposite sides. So trans or E can be used. But if different types of heavy groups on the opposite side, then we cannot use the term trans. It should always be E. Is it clear, this part? So in the next, they're asking why the stereoisomerism can occur in alkene and why hex 2-ene has stereoisomer but hex 1-ene does not. So when we draw the structure, like when I draw the structure of hex-2-ene, it can have cis or trans, sorry, E or Z. Cis is trans is not possible. So CH2, CH2, and CH3. So this I made Z hex-2-ene. But why, if I draw hex-1-ene, hex-1-ene means the first carbon should have a double bond. Then there will be a carbon chain 1, 2, 3, 4, 5, and 6. And they will have hydrogens. So as you can see, identical groups are there. So we cannot compare which one is heavy and which one is lighter. So if there is no comparison between heavy and the lighter, it cannot have a geometrical isomer. So this is question is of two parts and 2 marks. So first one, why stereoisomerism occur in alkene? So what is the reason? How you write this answer you will mention. Like the carbon double bond with carbon restrict the rotation or prevent the twisting. Or restrict the rotation. That is the reason. And then why hex-2-ene having a stereoisomer but hex-1-ene does not have? So in hex-1-ene does not have a different group at 1 carbon. That's why it does not exhibit stereoisomerism. Trans is also possible. We already drew the trans. They are not saying cis or trans. The basically why I use the term trans, you don't use the term trans here because the groups which are attached here are different types of groups. So you don't say that, in that case you don't say cis. Like I will not say it is cis hex-2-ene. That will be wrong because cis and trans are used when identical groups are attached. If their identical groups are attached on the same side, then cis. If identical groups are attached on the opposite side, then it is trans. So in this case, you can see the identical groups are on, they are not identical groups, so I cannot say this as a cis. I can also say only say it is Z. Question 13. Which of these compound will show a geometrical E, Z or cis trans isomerism? Yeah, what's the answer? Look, in this case, it's a skeletal formula, so it means 2 hydrogens are there. So this cannot show. When you check this one, the hydrogen will be here, so this cannot show because identical groups are there. For this one, CH3 and CH3. So it means this cannot show. The only one which can show a geometrical isomerism is B. Because in a skeletal formula, we do not represent hydrogen. Is it clear?